Welcome everyone to today's presentation on concrete flag pavements. This presentation will guide you through how to create a construction specification for flag pavement installation on flexible bases. This presentation is presented on behalf of the Concrete Masonry Association of Australia. Before we dive into our presentation, we're quickly going to look at some background information that will be of use. These being the relevant definitions and standards for concrete flag pavement construction. Flag pavements, by definition, are large format pavers which have an individual surface area equal to or greater than 0.08 meters squared. Pavers which are smaller are defined as segmental. On the right, you can see the typical structure of a flexible concrete flag pavement system, which has been labelled appropriately. I've also provided the definitions for your own understanding. I recommend taking some time to familiarise yourself with these definitions before moving forwards in the presentation. Concrete flag pavers are to be manufactured in accordance with the Australian New Zealand Standard 4455.2. This standard outlines minimum paver material properties with respect to the surface's functional use. The Australian New Zealand Standard Series 4456 dictates the testing procedures used to identify the aforementioned material properties. Australian Standard 3727.1 provides additional guidance for residential pavement construction. Before constructing a flag pavement, always remember to check local guidelines as additional requirements may need to be met before construction can occur. Throughout the presentation, I'd like to run through the following pavement example to facilitate learning. The example pavement is being used as a public space pavement. It carries high pedestrian volume with infrequent light vehicle movements. The pavement is to be built with a 1 to 15 slope, and the subgrade was identified to be a non-cohesive soil, comprising of mostly silt with some clay. The minimum characteristic breaking load is the minimum point load at which failure of the paving unit occurs. In Australian New Zealand Standard 4455.2, the minimum characteristic breaking load for various applications is stipulated. An excerpt from this standard is provided in Table 1. In our example, a public space pavement is used, and it is subjected to pedestrian and light vehicle activity. Hence, a 7 kN breaking load is required. This would be tested using Australian New Zealand Standard 4456.5. The dimensional deviation is the manufacturing tolerance between paving unit dimensions. The dimensional deviation can be measured using a 20-unit cumulative measurement or by an individual unit measurement. The Australian New Zealand Standard 4455.2 categorises the allowable cumulative dimensional deviations into one of four categories: DP0, DPA1, DPA2, and DPA3. This is dependent upon the determined variation in work size dimensions. As mentioned previously, the dimensional deviation may also be categorized for the deviation of individual units. For individual unit deviations, AS 4455.2 has 5 categories: DP0, DPB1, DPB2, DPB3, and DPB4. Again, paving units are categorized depending on the variation of work size dimensions determined. Australian New Zealand Standard 4455.2 specifies the allowable dimensional deviation for various pavement applications. An excerpt from this standard is provided in Table 2. As mentioned previously, we are using a public space pavement subjected to light vehicle loadings. Hence, a DPA2 or B2 dimensional deviation is required. This would be tested using Australian New Zealand Standard 4456.3. The abrasion resistance is the ability of a surface to resist wear by friction. Australian New Zealand Standard 4455.2 specifies the maximum allowable abrasion index values for various pavement applications. An excerpt from this standard is provided in Table 3. In our example, we are designing for a public space pavement subjected to both pedestrian and light vehicle movements. We have a high pedestrian volume, so the maximum abrasion index value for our paving unit is 3.5. This would be tested using Australian New Zealand Standard 4456.9. Slip resistance is the frictional force opposing the movement of an object across a surface. Australian Standard Handbook 198 specifies the required slip resistance classifications for various pavement applications. An excerpt from this standard is provided in Table 4. In our example, we have a slope of 1 to 15. Hence, a P4 slip resistance classification is required. This should be conducted in accordance with a wet pendulum test. The minimum flag paver thickness, as specified by Australian New Zealand Standard 4455.2, is 40 mm. Flag pavers, which are thinner than 40 mm, cannot be used in accordance with this standard or the other testing standards mentioned previously. For our example, we are designing a public space pavement, subjected to both pedestrian and light vehicle activities. Hence, a minimum thickness of 50 mm is required. The base material of your concrete flag pavement should be made of a well-graded unbound crushed rock. It should have a maximum clay content of 6% by mass. The following grading specifications are recommended by the Concrete Masonry Association of Australia and its member manufacturers. In our example, we will be specifying the use of the Class A Basecourse material. The soil in the subgrade will play a crucial role in determining the thickness of the Basecourse required, and will need to be identified by a physical assessment. Non-cohesive soils like sand and silt will feel sharp or gritty when rubbed between fingers, whereas cohesive soils such as clay can be easily molded into shapes and will stain your fingers when rubbed. The CMAA recommends the following Basecourse thicknesses as a rule of thumb when constructing concrete flag pavements, shown in Table 7. For our example, the subgrade has already been identified to be mostly silt with some clay. The traffic loadings were also identified to be pedestrian and light vehicles. Thus, the required thickness of the pavement can be easily determined to be 75 mm. Bedding and jointing materials should be a coarse, well-graded washed sand free from organic and deleterious materials. The grading limits provided in Table 8 are recommended by the CMAA and its member manufacturers, and should be observed during construction. Bedding sand should be laid and screeded to a thickness of 25 to 30 mm on the prepared base course during construction. Jointing sand should be swept into pavement joints and compacted after the pavement has been laid. With that, we have now wrapped up the worked example and now have a complete concrete flag specification that we can use to source materials and plan for construction. In summary, the paving units should have a minimum characteristic breaking load of 7 kN. They should have a dimensional deviation category of DPA2 or B2. The maximum abrasion resistance index should be 3.5. They should have a slip resistance category of P4 or better, and should have a minimum nominal thickness of 50 mm. The base course shall be laid and compacted to a 75 mm thickness. The bedding sand shall be laid to a 25 to 30 mm thickness, and the jointing sand shall be swept into all joints to ensure that they are filled. The base course, bedding sand, and jointing sand should meet the material specifications outlined previously by the CMAA. Something else you may want to consider is the appropriate laying pattern for your pavement. Herringbone is recommended, however alternatives like basket weave and stretcher bond can be used when designed and constructed appropriately. The continuous joint of each pavement configuration must run across the direction of travel, which is shown in Figure 2 of this presentation. Another important consideration is the provision of edge restraints. The entire perimeter of the pavement is to be constructed with an edge restraint. Edge restraints shall sit within 100 mm of the compacted base course or subgrade. Some suitable edge restraints include vertical edge bricks laid in a small concrete trench, an exposed or concealed concrete beam, an existing wall of a building, or barriers constructed using a pre-mixed concrete with 20 MPa strength and 14 mm aggregate. Detailed drawings of some common edge restraints are provided on this slide. Another important consideration is the crossfall of your pavement. A minimum fall of 2% is recommended by the CMAA to facilitate the drainage of water off the pavement surface. Gradients less than 10% can be achieved with little to no difficulty. However, gradients larger than 10% will require professional consultation, should they be required. If you want to learn more about concrete flag pavements, I recommend viewing CMAA Manual PA05 and datasheet Concrete Flag Pavement Material Specification. These provide a more in-depth look at design and construction requirements and will prove to be an invaluable resource moving forward for you. This wraps up the concrete flag presentation. If you're interested in learning more about concrete brick, block, or pavers, be sure to visit our website. We publish a comprehensive catalogue of technical manuals, research papers, and case studies, all available for free. We also have a technical hotline, which we encourage you to call, that provides free design and construction guidance, should you need it. We hope to see you watching our other presentations in the near future.